In this video, I'm going to go over the warm-up for our Unit 4 Day 3 quiz review. Hopefully you've completed these problems already at the beginning of class, and this video should just help you check those answers and make sure you understand how to do these problems. So in the first one, we're supposed to graph triangle ABC with vertices A, 1, 0, B, 2, 1, and C, 4, negative 1, and its image after a reflection in the line y equals negative 1. So the first thing you want to do on these problems is make sure that you've graphed the original correctly. So the original triangle, ABC, A is at 1, 0. Make sure we label it. B is at 2, 1. And C is at 4, negative 1. Make sure we connect these. And then we're going to reflect that in the line y equals negative 1. Now, when I say the line y equals negative 1, you need to understand when I have y equals some constant number, that is always a horizontal line. Okay? Y equals a number is always horizontal. For instance, in this case, when it says y equals negative 1, I'm going to mark negative 1 on the y-axis. And I have to graph horizontally because that's the only way for y to be consistently the value negative 1. On all these points along this line, y is equal to negative 1. So we're going to reflect our triangle over that. So the easiest way to do this is just to notice that any of these points are going to take the same distance above the line and repeat that distance below the line. So like A is 1 above, so I'm just going to move it 1 below. That's how I get the new coordinate, A prime. And those coordinates would be positive 1, negative 2. So A prime, with that little apostrophe, that's how we call that A prime, is at 1, negative 2. B is 2 above the line, so I'm going to move it 2 below the line. So B prime would be there, and those coordinates, again, we go back to our original 0, 0 here. The coordinates for B, if I were to graph that, would be 2, negative 3. And then C is exactly on the line. So C prime stays on the line of reflection as well. And so C and C prime are the same point. So I can connect these, and you can see that's a reflection over that line. So the original coordinates for C and then the new coordinates for C prime are the same. Okay? On the next one, number 2, we're told to translate the triangle GTB using the rule xy maps to x minus 2, y plus 3. Well, they've already given you the original, so all I have to look at is how to change x into x minus 2 and y into y plus 3. With the translation, remember that's sliding left or right and up or down. Since it's x minus 2, that moves my x values to the left, 2. And y plus 3 means I'm going to move the y values up 3. So this entire graph is going to move to the left 2 and up 3. So I start with each point. G goes to the left 2, up 3. Puts G prime right there. T moves to the left 2 and up 3. There's T prime. And B moves to the left 2 and up 3. There's B prime. If I graph those together, I get the new triangle. So that's what a translation is. Adding to the x's would move it to the right. Subtracting from the x's moves it to the left. Adding to the y's moves it up. Subtracting from the y would move it down. On this one, number 3, we want to write the mapping rule for that transformation that's already been done for you. So it's like I'm taking this triangle and turning it into this triangle. Okay? In order to do that, I'm just going to pick one of the points. Let's pick point X. That point moves to the right 4 and up 2. Since my point X moves to the right 4, I'm going to take the X values of that ordered pair. I'm going to add 4. And since it moves up 2, I take the y values and I add 2. And so that's how you can write a mapping rule based on the transformation that's already been done. And this is a translation because we're just sliding to the right and up. And in any translation, all we do is add to the x's or subtract from the x's and add to the y's or subtract from the y's. For number 4, we're told to graph triangle ABC with those vertices and the image, remember that's the result, after a transformation. And this is the transformation we're doing. We're going to rotate 180 degrees. So the first thing you should have done is graphed the triangle. This should be triangle ABC. That's the original. And we're going to rotate it 180 degrees around the origin. You might remember that the mapping rule for a rotation of 180 degrees is negative x, negative y. Okay, you could probably have found that in your notes from our lesson on rotations. But all that means is we're turning this exactly upside down. We're taking the opposite of the x's and the opposite of the y's. Okay, the key word is opposite. So when I'm graphing this, when I graphed A, to graph the point negative 3, 2, I went to the left 3 and up 2. So I'm going to turn those directions exactly opposite. Instead of to the left 3 and up 2, I'm going to graph to the right 3 and down 2. So there's A prime. Same thing for B. For B, I stayed at 0 for my x, but I went down 1. So I'm going to stay at 0 for x and go up 1. There's B prime. And the same idea applies to C. For C, when I graphed it, I went to the left 4, down 2. So I'm going to go to the right 4 and up 2. There's C prime. And if I connect those 3 points, I get the new triangle A prime, B prime, C prime, and it can be seen as a rotation of 180 degrees around the origin. But when I have negative x, negative y for a 180 degree rotation, all you do is the opposite of the x's and opposite of the y's. All right, and the final 2 problems talk about symmetry. One of the things we talked about with symmetry was rotational symmetry. And that's where if I rotate the figure 180 degrees or less, and it looks exactly identical to the original, it has rotational symmetry. So with this regular pentagon, you can see we can rotate this several times less than half a circle, or several times even less than a full circle, and it still looks exactly the same as it does here. So, for instance, I could take this point and rotate it up to the top point, and it would look the same. I could keep rotating, and it would look the same. And you'll realize we could do this 5 times. So yes, this has rotational symmetry. And to describe the rotations, there are 5 of them. Okay. Another way to describe the rotations is to take a full circle, 360 degrees, and divide it by those 5 possible rotations, or those 5 equal sides, and get that each rotation would be that result. Well, 360 divided by 5, if you were to get a calculator out, would be 72. So we could describe these rotations as 72-degree rotations. Okay. Finally, number 6, you're to determine whether the figure here has line symmetry. In order for a figure to have line symmetry, remember that I should be able to draw a line of reflection so that reflecting over that line makes it look identical to the original. Well, there's really only one line I could draw. That would be this line for a reflection line. But because I can draw that, it does have line symmetry. And it has that one line. Now, other figures might have more than one line of symmetry. Okay, there could be 2, 3, 4. It just depends on how many you could draw, where reflecting it over that line makes it look exactly the same. I hope this helps you as you have prepared for your quiz. You should be ready to take that quiz now.